So hello everyone, I'm here to show a little bit about my software. So we developed the GUI to visualize and to generate faults. So basically what we do, we come here, we put to run out, and then we are going to have our GUI here. So here we can generate the initial routes. We can also recalculate the rows when we have a broken vehicle, and if the vehicle uh, can put it back to our system, we can include it here. So right now, what we are going to test, we are going to test our optimization from the paper that we wrote, that was written there. So there we simulated using the vehicle number 21. So that's what we're going to do. So first we need to calculate the initial roads. So it's going to calculate the initial roads here. So we can see that it's calculating. Um, we need to wait 1 minute because was set there to be 1 minute. Let me just check. We set the time for the actually wasn't 1 minute is more than 1 minute, was 200 seconds, so we wait for that. let me let's go back here. So is calculating the roads is going to take a while, so it's going to take this 200 seconds. But meanwhile, I'm going to explain a little bit. So here is calculating the cost. So the cost now is at 67,400, about 400. So the maximum that it got was that, and this is the time that is running. So here we can see about our optimization process. And for this one, we used the algorithm table search that, according our experiments, was the one that achieved the best cost. However, it depends a little bit for how long you're going to run the algorithm. Some of them, they converge faster. So right now we have time because it's the algorithm to calculate the initial route. So we are not really worried about how long it is going to take. We are more like worried about getting less cost at this first moment. However, when we recalculate the roads that is here, then we wanted to do it fast. So we have 10 seconds. And for this one, the best algorithm was the simulating annealing that got the smallest cost value in 10 seconds. So that's why we set different algorithms for that. Is still running. So the our initial initial calculation initial calculation. So what else? So basically here we can also see the vehicle number. So when we want to simulate the faults, we put the vehicle number. For in this case, we're going to simulate using the vehicle number 21. Then here we put the time that you happen that fault. Then we put it the station and the pair. So where the vehicle was traveling. So in this case, it was traveling to station 110 to station 245. So here we can also see, I can show you, we can filter here. Uh, I'm going to run. So here we can filter to visualize better. So is the 110, 245 the stations. Let me. I sorry, I need to grab both here. Okay, and them is going to use the station. This one. I'm going to put all so you guys can visualize as well. Okay. So here we can see. I'm going to show you. So here we have this station 110. I'm going to travel to station 245. So where is going to stop? We have two stations in this path. So it's going to stop here because it's closer. Okay, so it's going to. I mean, we're just simulating. We could like also simulate this one, but because of the time that it was close to the time that is going to take off from here, is going to be closer to this station. Okay, so these are the other emergency stations. So let's go back to our GUI. Okay, so we are here. So here you can check how many vehicles are in the system. So we have 63 vehicles. So we're going to use the vehicle 21. Then we have at 740 uh, MM25 OG pair. So I'm putting 110, 245. So before I do this, I would like to show this here. So this is the vehicle path. So the where the vehicle is going to fly and what time. So we have the vehicle 21. So we have here the vehicle 21, and the vehicle 21 is at station 110 at 7:30. And then we is going to fly to station here 244, and is going to get there about 8:16. So when I'm going to simulate this you change according to this optimization system, right? So let's generate here. So it takes a little bit to simulate. So now it's simulating, is recalculating the roads. And then now we have there one broken vehicle, right? And the vehicle is at 21. Oh, sorry. A vehicle is 21 at EM24. That stands for emergence 24. So now we can check again. So we here now have the vehicle 21 is at station EM25 at 7:40. So guys, this is a little bit about our system. Is going to be available on GitHub. So if you have any questions, if you want to also send some feedback about it or propose new ideas, our next steps is to include the supervisory control theory to this optimization problem to so then we can also handle climate problems, weather problems, and also give a little bit of sense of safety. So thank you so much. Bye bye.